The year was 1976 when this tape deck was born. This is an AKAI. It's got glass heads and it's a cassette deck. So for those thinking that they didn't make glass head cassette decks, they did. And I have one today. This one was sent in for service and it needs a fair bit because this one looks like it may have been dropped. Let's check it out. I have an AKAI GXC 3110D, and for those that were wondering if the glass heads was only used on reel-to-reel decks, well, that's not correct. They're also used on cassette decks, and this is one of them here. Glass and crystal ferrite head. This one was shipped in from a viewer to have checked over, and we're going to give it a test first, see what it's doing, what it's not doing, and see if we can get this one up and running. I've connected it to my power amplifier. First thing we'll do is turn it on, see whether it powers up. Our meters are both lighting, which is a good sign. And we'll see first of all whether we can pass a signal through it, through the record inputs. So we'll just set the record levels up, and to enter the record mode I just need to, well, we'll try playing a tape first. Let's see first of all whether there's any tape movement, and then we'll see if we can pass a signal through it. So I've got a cassette tape here which should have something recorded on it. We'll check it first of all and see whether the tape moves. Fast forward works, rewind works, and playback. Oh, I've got something on one channel, but nothing on the other. Is there anything recorded on this side of the tape? That's a question. Let's see. Turn the tape over. I'm pretty sure there's something recorded on this tape somewhere. Oh yeah, I've got tones on here. Only one channel is playing back though, as you can see. One channel is completely dead. And actually that's a fault with the machine, because you see as soon as I put it into playback, even without a tape in it, I'm getting this noise. So that tape may actually have some music recorded on it. I forget which tapes I've got tones recorded on and which ones I have music. We'll just give the record play switches a quick check over by just pressing the record button and activating the switch a few times to see whether our fault is just a dirty switch. Okay. Now it's not making that horrible noise. Let's see if it'll actually play something. We just may have a problem with dirty record play switches. Aha! We have sound. So, first things first, let's clean the record play switch, because that's probably all that's wrong with this machine, is the record play switch is bad. How's the tape counter? Is it working, or is the belt shot for that? Looks like the tape counter belt may be bad, because the tape counter is not moving, and typically it's driven off of the take-up spool and it's not turning. So the tape counter belt is probably missing or shot. But first things first, let's get this unit apart and clean the record play switches on the unit and see how it performs after doing that. As this is a customer's machine, if it's my own equipment that's I don't care about, because in case you guys haven't noticed, when I'm working on my own stuff, I typically don't bother to protect it, because a lot of times, you guys might not know this, I'm probably going to tick a lot of people off now, but a lot of times when I'm working on an old piece of equipment of my own, I don't care what happens to it once it's done service, because I'm either going to give it away or I'm going to sell it, so or throw it out. A lot of times equipment that I work on for my own is stuff that's headed to the recycle bin when I'm done with it. Screws out of the bottom cover lifts off just like that to reveal a dual caption system with a belt drive. Now, even though the belt is old, it probably doesn't need to be replaced, because these ones are not designed to be super tight. If the belt is too tight, you're going to end up with excessive wow and flutter. They're actually designed to be fairly loose. As long as the pulleys or the flywheels turn, which they do, we're probably okay with the belt. Here's the counter belt here. Wonder why the counter's not turning. Belt's not broken. Anyway, what I'm looking to get at is these record play switches here. So to do that, oh, the circuit board's broken. Look at that. This one here has been banged around, it looks like. The board's supposed to be like that, and it's snapped right there in the corner. These are always things I do before I do any work, is I do a full visual inspection, and I document everything on video, just so that the guy can't turn around and say, and the board's broken over, oh look, there's some traces broken over here in the corner here. So the owner can't say that I did the damage. You see here? There's a couple traces here that are going to have to be repaired. So this is not going to work until I repair those. And that's probably part of the reason why one channel is as low as it is that the board has a break in it. So the first thing I'm going to do is I'm going to remove the board, and we'll clean those switches up, and then we'll have to repair the damaged traces where it's broken. This one's broken over here too, but at least on this one, on the back of it here, you can see there's a trace here, but it's not doing anything. The trace is not damaged. Corner's just broken off, but the front here, yeah, this one's got a break on the trace, so we're gonna have to repair that. But first things first, let's take the board out. We'll clean the two switches and get this back up and running, see if it'll make recordings and playback, and then we'll go from there. As I say, I'm not too worried at this point for the belt. And also, this is being a dual frequency system. You'll notice that to run it at 50 hertz, you actually have to remove the belt and move it up to a different pulley, because this is an AC synchronous motor on this unit. It's not a DC motor. There's a switch here for 50 hertz. That just changes the capacitor. To run this at 50 hertz, you actually have to move the belt up to there. And that will increase the speed to the capstan shafts, because, of course, at 50 hertz, the unit's going to be running, or the motor's going to be turning slower. For 60 hertz, it's run on the bottom pulley down there. So that's how you change the frequency on a machine like this. Up on the outer capstan, there's a little diagram here. Outer capstan shaft for 50 hertz, inner capstan shaft for 60. And the same applies to all the reel-to-reel machines that use a synchronous motor. So there's no speed adjustments to do on this. The motor itself is synchronized to the AC line frequency. So we'll never have to adjust the speed on this. If it's going slow, it could be the run capacitor is going bad for the motor, which is typically a big AC capacitor, typically rated at like 450 volts. Maybe a Mylar capacitor or maybe an electrolytic, but there will be a capacitor in here. I'm just looking to see if I can spot it. The motor run capacitor on here. There will be one somewhere buried in here. There's a motor run capacitor. It might be on the other side. But the motor's turning, and the motor's got lots of torque. Therefore, the run capacitor is fine. Okay, unplug the power. Let's take out the circuit board, and we'll repair it and clean the switches. This was in a very heavy box, because there was not just this, but there was other stuff shipped in the box. So I'm curious as to whether the carrier, Canada Post in this case, I'm curious as to whether they threw the thing down, dropped it, or I don't see any damage on the box. Well, no, I don't see any damage on the box. I'm just looking at the box. It was a box within a box too. Like the fellow that sent me this, I think he's probably an eBay seller. You wonder why I think that? Because it was all sealed up with like eBay tape, and the boxes inside say eBay on them. So I have a feeling the guy is probably an eBay seller, and he's probably wanting to get this thing fixed so that he can sell it to somebody else, and he put it in his eBay box. So it was packed up quite well. It was a box with inside a box with all kinds of packing around the edges. So, and this corner is cracked as well. Another piece just fell off. This whole thing has been damaged, right? Because I just went to move this, and this piece just lifted right off. So this corner is also damaged with traces that are broken that are going to have to be repaired. Probably far enough to get at the switches. The switches are right here. The two switches that I have to clean are right there. So I've got that up enough I can get in there with some cleaner. And we'll give those switches a good shot of neutral. That's what I'm going to use on this, is neutral. Neutral is one of the best cleaners that I've come across. It's a toss-up between deoxit and neutral. This is old neutral. This stuff was fantastic. The stuff that they make today is alcohol based. This one here is not alcohol based. Look at the makeup for this one here. Okay. Not alcohol. This stuff is Freon based. This is the good cleaner. And I think that if you can get your hands on a can of this stuff, which you're never going to find today, unless you find a shop that's gone out of business and maybe has some old stuff kicking around. If you can get your hands on this stuff, there's nothing really that can beat it. Deoxit's very good. The Deoxit D5 is very good, but I think that the original Neutral is better. I got about a half a can of this thing left, and I don't know if I can get any more. So I will have to use this sparingly, just like I do with the with my Deoxit. Because this is good cleaner. Okay, I'm just going to put this back in place, and I'm going to repair the board. I'm going to put some epoxy over here too, just to repair the damage, give it a bit of strength, because there's not a heck of a lot of strength to the board here. Broken in three places with three corners missing. We're going to have to glue this back in place. I'm going to mix up some epoxy. We'll get that part taken care of, and then I'll deal with bridging the broken traces. Okay, I've got some JB Weld mixed up, and before anybody says it, yes, I'm aware JB Weld has tiny little metal particles in it, but it's not going to cause a problem here because I'm not going to be putting it over where circuitry is. I'm just going to put the JB Weld, a little bit of it here on the edge of the board, just to hold the piece in place and reinforce it. And I'll put my jumper wires over the top. And it is not conductive, as though some people might like to think that it is. It actually is not conductive. Even though the metal particles, in theory, metal conducts electricity, it is also in an epoxy polymer, which is plastic. So, not conductive. I'm just going to put some along the edge here just to reinforce the joint a bit. Same as on this edge here. And back here in the corner on this edge. Okay, so I'm going to leave that one out until the epoxy hardens, because it appears that the chassis may have a slight warp to it. That's going to put a bit of stress on the board. So we'll leave it until it completely sets up so that it doesn't pop this apart again. And then I'll repair the board. I get the sneaking suspicion that at some point in its life this unit was bounced. Probably dropped flat onto the base, and since the base is attached to these metal tabs here, impact bent the chassis that holds the board slightly, so it's not holding it straight, but that should not be an issue. We'll let the epoxy dry up here a bit, and then we'll continue on this one. Okay, the glue is dry. Let's repair the board now. So I'm going to be putting some jumper wires over the damaged section of the board in the corners here, and these two corners anyway. This is where the damage is this corner and that corner. So we'll put some jumper wires in place. Probably overkill for wire that I'm using. Just using what I've got at hand here. So I'm going to put a bridge over here on this one between the bit of the solder mask that I've scraped off and the next connection over. There's only a couple breaks. Not like it's a huge break, but it is a break nevertheless. So we'll just put some solder on the board. Okay, that's one. The other one's over here. We'll take care of that one. On this side, there's two traces that are damaged. One runs right here. It's broken in two places, and then the other one is from this one here. So I'm going to jump her from here over to there for one. Okay, that's one trace. The other one is the outside trace over here. So I'm going to take it from this connection down to here. Continually going to remove the wooden frame from it. Okay, I've got the wooden side off of it now, the base. I want to clean the input selector switch here. These switches and the level switches need to be cleaned on this unit. If I put it into record mode, we're now going to pass our signal. Actually, that's a little bit of static on that control. Actually, you know what? The switches don't sound bad at all. Just the output control. Just that one control is a bit noisy. So we're going to clean the output control. The other ones I don't need to touch, they're clean. Otherwise they'd be. Trying to figure out how I'm going to get into that control. I can see it right down the side here. So I should be able to hit it with my extension here on the neutral. There we go. There. That control's sounding good now. Okay, that part's now fixed. Now, check out that tape counter because it wasn't moving. So that's supposed to go when the tape is turning, either fast forward or rewind. I'm sure it's on the fast forward side, and the little tape run light should move, and they're not. So of course that will cause the unit to go into a auto stop. It's this belt turns this. There's a little reed switch here that detects whether this magnet is turning, and that's what determines whether it stops or not. And this should be turning, but it's not. Put it in fast forward. To play. And that's because this is not turning. Obviously, this belt is slipping, and that's why this is not being turned. But it could be the belt, or it could be the counter is itself, the shaft itself is sticking, because it seems to be relatively stiff to turn. To access the belt, I'm going to remove flywheels. and the main drive belt. Here's our belt down here for the counter. So this is the take-up hub, and we know that it does turn. I'm just going to see if I can find a new belt that will work, that's got a little more tension than this one. Although that one should work, it seems like this is kind of stiff. This is the shaft that turns the tape counter and also operates the reed switch here. That's free turning. It might be this shaft here is sticking. Let's just take a look at that. I'll take out this little circuit board here. So lift this out of the way. I'm just going to put a little bit of lubricant, which I've just done, onto that little worm gear that's below here. Put a drop of oil on that little worm gear down there. You can see it where it meshes with the little white gear, and now look at how free this is turning. It was kind of sticking before. I think just the lubricant got a little bit dry down there. I'm just going to put a bit more on there, a little bit of grease, and hopefully that's all it is this. The belt is probably okay because the belt wasn't broken, and this belt is not supposed to be very tight because you don't want to put any excess strain on the take-up spool. You don't want to stop it from turning. You just want this to freewheel, and now it does. It freewheels nicely. So now if I turn the tape hub by hand, you'll see that the tape counter is turning. So the belt that's in there is fine. No problem, because it doesn't need to be a high torque belt. And you actually want it to be a low torque belt for the reasons I explained. You don't want any excess forces on the take-up spool. Too tight a belt could stall out the take-up spool. So you want to have just enough torque to turn this. So what had happened is this got gummed up, and that's why it wasn't turning. So now we'll put the screw back in here to bring the reed switch close to the magnet. How these auto stop systems work is this magnet rotates and it causes this little magnetic reed switch to open and close. So the system monitors the on and off pulses generated by the reed switch. And if it exceeds a certain time, which is this timing board back here, I believe, this is the timing board here. If the time between open and close exceeds so many seconds, time runs out. Basically, it's keeping a capacitor from charging. So there's a capacitor on the board that is being charged up, and when the switch closes, the capacitor is discharged, or vice versa. The capacitor discharges, and when the switch closes, the capacitor charges. Regardless, either way, it's a time constant. If the switch is opening and closing, the capacitor is kept discharged. If the switch stops, the capacitor will charge up. Once the capacitor charges up, it'll trip the stop sensor. Now, it's a two-way street. If the capacitor stays discharged for an extended period of time, it will also trip it. But it's quite a simple circuit that they use, just timing whether the switch is open or closed. So we'll just put a drop of oil on the capstan shaft. That'll get into the bearing. Now I just have to reset the idlers. Just like that. Okay, ready to power up. We'll see whether this turns freely now, which it does. I'm in fast forward mode, I believe, right now. As you can see, this is turning fine. If I stop it, it'll automatically kick the auto stop after a few seconds, like that, which is what it's supposed to do. That part appears to work now. Let's turn this thing over and see how it sounds. We'll play a tape on it before I put it together and try a recording, see how this thing sounds, whether it's actually going to work, and then get it back together. So the problem on this, of course, was the tape counter was sticking. There's a little worm gear, and it turns into a little plastic gear, and it was sticking. So I put a bit of lubricant on there. I should put a little bit of the Molykote grease on there. That will keep it from getting gummed up again. So here's the gear down here. I'm going to lubricate. I'm just going to put a bit on that gear so that when the unit is, see, now it'll lubricate that. Because it doesn't take much to stop it, right? If I stick the screwdriver in there, it will stop it. Might not hurt to put some more on the other gears over here too. There we go. That should keep the tape counter turning freely for years. You know, why do people always choose when I start to film to turn on things like leaf blowers? It never ends, right? Okay, let's try loading a tape and play it back. This is a pretty quiet song here. We'll just rewind this back to the beginning. As you can see, tape counter's moving nicely now. And then we'll grab another tape and do a test recording. You notice this one here can record low noise, standard tape, chrome, and if you press both of them down together, it's ferrochrome. Should auto stop here, which it does. It'll play. Can clean the heads on this unit first, and I'm going to make a recording. I got lots of tapes that I can use for testing. I thought I was going to get a break there, but nope. Bloody leaf blower going again. Clean the heads. Put it in play mode without a tape. Good old cotton swab. And just wipe the head down. It's right here. This is the glass head on this one. And the erase head is right next to it. Being a dual capstan design, between both the capstans, both the pinch rollers. Yeah, a little bit of debris on it. Well, shit happens, as they say. I'm busy recording. I thought I was recording, and my camera had shut down because somehow the AC power cord came undone, and thing's been running on battery all along, and the battery finally gave out on it while I was making a test recording, so I don't know if I even got anything. I wasn't looking at the monitor, so we'll start over again. I've got my levels set. I'm going to put the machine in pause and record and play together. Our level is set. Let's release the pause, and we'll start this again. I'm recording this without Dolby, no Dolby on this. Okay, that's recorded. Let's rewind this one and play it back and see how it sounds. Of course, we have to put up with the leaf blower again. Actually sounds pretty good for an old tape deck. We're going to try the same thing again. This time I'll do it with the Dolby on. So let's find another track. Release, pause. Dolby is on. Play. sounds good. Sounds fantastic. We'll do a couple more tests on this thing without the Dolby. I'm going to record a couple test tones and play them back and see how the test tones come back level-wise. So I'm just going to grab my tone generator, which I just so happen to have right next to me. And we'll record a couple of different test tones at different frequencies. We'll see how this handles it. This is being an old machine. I'm not expecting the frequency response to be all that good because it is pretty ancient. But it should record up to 12 or 15 kilohertz, I would think, without too much of an effort. Go to record, I'll turn this thing on, and yeah, I don't think we'll be starting it there. Let's start out at 1 kilohertz. Record a 1 kilohertz tone at 0 dB or thereabouts. It's pretty close. Maybe a little bit hot. There we go. 0 and 0. Coming back pretty close. A little bit low on the right channel, maybe a dB down. Still looking pretty good though. Okay, we'll try it again. We'll try this at, let's see here, what do we do this time? Let's try this at 5 kilohertz. Oh, my levels weren't even set quite right. That might explain it. I got a reflection problem here with the lights shining in my eyes, so I couldn't see the meter properly, but there we go. 0 dB. 5 kilohertz. I'll just save you guys ears a bit. A little bit of wow. That's okay. It's an old machine. We'll try this again. Let's go to 10 kilohertz this time. 10 kilohertz. Am I annoying you guys? Oh, listen to that distortion when I crank it up. I expect that 10 kilohertz is probably going to be, yeah, not quite as much there because, again, we're down by 5 dB. Again, with the hiss, it's there, but you got the background noise. And, well, I don't think it's even worth going to 15 kilohertz because I don't think this thing ever could record to 15 kilohertz. In fact, they guarantee it probably doesn't go beyond about 12. Let's try 14, just for the hell of it. We're probably going to be getting into the bias oscillator range. We'll hear some beating with the bias oscillator, I'm sure, when we get these tones up there. But it'll give you an idea what this thing's capable of. Again, it's a ferrite head. It's not a high performance machine. This was early cassette decks. And as you can see, you're wondering why you're hearing a low tone. That's actually my test tone beating with the AC bias oscillator. So a machine like this, I think the frequency response, I haven't even looked it up, but I bet it's like 100 to or 80 to 12 kilohertz. I would think 10 to 12 kilohertz is probably all this thing is even rated for. And I tried to record 14. So let's try 12. See if it'll do 12. Sorry for the ears. How many dB is 12 going to be down? Yeah, even 12. It's pushing it. Anyway, let's get this one together. Test it out once I get it together. Now that the unit's back together, we're going to try out the limiter on this. So I've got the levels cranked as high as they can go because, of course, the limiter is for people that don't know how to make recordings. This should be interesting to see how well the limiter works on this unit. Now, for those of you that don't know, the limiter is an automatic level control. See the peak level lights working on here too? Normally you don't use a limiter. You set your levels accordingly so that your peak light is just coming on or just on the very highest peaks. I just want to test all the features on it right before sending it out. So let's rewind this tape. Oh yeah, I should use the memory on this. Make sure it stops at 0. Yes, it does. So here's the limiter on it. Never fails. Never fails. As soon as I go to do a critical listening, that jerk across the street has to turn that bloody leaf blower on again. That thing has been going now for, well, it's 5:45 at night. And it's been running since around 3 o'clock, on and off. Okay, he stopped again for like the next 10 seconds. Actually, it's a worker. I can't win. I can't win. This is maddening. Every time I go to do a critical listen, that bloody leaf blower comes back on again. It's a guy cleaning the neighbor's gutters. Hope he falls off the roof. Can I do it now? Will I have 5 seconds of silence? Sounds like it's running a little hot, doesn't it, with the limiter on? Which is to be expected because limiters are not something you should ever use. Why they even included it on here? I think that the manufacturers felt that when they brought out a tape deck like this that people didn't know how to use VU meters, so they had to make it automatic. But a limiter is something you're never going to use, and you know, it's a useless feature. It's only good if you're recording from a microphone and you aren't able to ride levels. Then it comes in handy, but for recording from the line level inputs, forget it. Anyway, this unit is fixed. Hope you enjoyed the disassembly and repair of this AKAI GXC 310D. As you can see, the belts on this thing are ancient, but there's nothing wrong with them. And that's just because the different compounds that they made the belts out of. Synthetic versus natural rubber. I don't know which ones were the bad ones, whether it was the natural rubber ones that failed and the synthetic rubber ones that didn't, or vice versa. I do know that that there were certain ones that were produced in the 70s and 80s that lasted forever, even into the 90s that lasted forever, 60s, right? There were belts that were made that never failed, ever. And then there were others that after, even 5 or 10 years, they got all slippery and gooey and melted, literally. So I don't know myself whether that was the natural rubber that deteriorated or whether that was the synthetic ones. If someone knows whether the ones that failed were synthetic, please post in the comments. But anyway, that's this one. Old belts, they're not slipping, and everything's working. As you can see, there he goes again. Full torque, fast forward, rewind. All the functions are working. Pause works. All the lights work. Yes, it does light up. It's just hard to see in here, but it does light up. Everything's working on this thing. Circuit board repaired. Guy that owns this will be happy with this one. Thanks for watching. We'll catch you in the next one real soon. Bye for now.